Hello, welcome to another episode of Physics is Easy with Mr. Jesse. This tutorial aims to solve a problem related to flat mirrors. This is one of the problems I have given in WebAssign. It reads two plane mirrors stand facing each other 2.95 meters apart. So we have these two mirrors here, and these mirrors are separated by a distance of 2.95 meters. So that's the distance between the two mirrors. Okay, and a woman stands between them. The woman faces one of the mirrors from a distance 1.20 meters and holds her left arm out to the side of her body with the back of her left hand facing the closer mirror. So the distance between mirror, so let's call this mirror 1 and mirror 2, the distance between the woman from the mirror 1 is 1.20 meters. Alright, now this problem can be depicted by this illustration here. So wherein we could see the first image, the second image, which is the image of your back, and the third image. Now let's proceed to, we will know more about this illustration as we move along with the rest of the problems. Now, what is the apparent position of the closest image of her left hand? So that's question A, measured perpendicularly from the surface of the mirror in front of her. Now, to answer this question, we must always remember that for flat mirrors, the distance of the image in front of the mirror, or at the back of the mirror rather, should be equal to the distance of the object in front of the mirror. So going back to this first question, since the woman is actually 1.20 meters in front of mirror 1, so therefore the image should be seen 1.20 meters, so that should be meters, 1.20 meters behind the nearer mirror. So this means that this distance here is also 1.20 meters from the mirror, from this mirror. Does it show the palm of her hand or the back of her hand? So since it is said here that she holds her left arm out to the side of her body with the back of her left hand facing the closer mirror. So it is the back of the left hand that is facing the closer mirror, so which is mirror 1. So therefore it is going to show the back of her hand. Now let's proceed to question C. What is the position of the image behind the nearer mirror? So this is our illustration earlier. Now we can see that the woman is actually standing with her back facing the second mirror, or mirror 2. So we could also see that somewhere here is a reflection of the woman's back. Alright. Now this let's call this image as image 2. Now this image 2 gets reflected on mirror 1, and we would see this reflection of the image 2, which we're going to call image of image 2. Image, oops, let's erase that. Image of image 2. Okay. So we actually need to solve for the distance of the image of image 2 from mirror 1, and let's call that di. So basically, according to the law of flat mirrors, the distance of the image is just equal to the distance of the object. Therefore, in order to solve for di, we must be able to solve for the distance of image 2, from mirror 1. Alright, and that is just equal to di is just equal to the distance between mirror 1 and mirror 2. It's just equal to, let's say, distance of mirror 1 and 2, and mirror 2, plus the distance of image 2 from mirror 2, which is, let's call that D2. So this is D2. Alright, we already have our distance between mirror 1 and mirror 2, and based on the problem, that is 2.95. So we have 2.95. Okay, meters. Now we just need to solve for our D2. How do we solve for D2? Very simple. D2 is the distance of the image 2 from mirror 2. And what is that equal to? That is just equal to this distance here. It's just equal to x. Alright, so remember, it is still based on the fact that the distance of the image should be equal to the distance of the object, or shall I say the distance of the object, which is this, should be equal to the distance of the image from mirror 2. Alright, how do we solve for x then? Now, since the distance between the two mirrors, is 2.95, and we know that the woman is standing 1.2 meters in front of mirror 1, so distance 2, or D2, or our x, is just equal to 2.95 minus 1.20, and that is equal to 1.75 meters. So we now have our D2, which we are going to put here. So DI would just be 1.95 plus 1.75, which is going to give us 4.7 meters, and that is our DI. Question D. Does it show the palm of her hand or the back of her hand? Now, here we could see, or we were able to determine that this image shows the back of her hand. After all, according to the question, she holds her left arm out to the side of her body with the back of her left hand facing the closer mirror. Now, since this is the image of the mirror on her back, or the farther mirror, or mirror 2, this should be showing the palm of her hand. And that concludes the tutorial, and let me end it by saying physics is easy with Mr. Jesse.